Okay, so I hope everyone is feeling great after lunch and a short break. We are changing gears a little bit, and this presentation will be a little bit more technical. Before we deep dive, I want to have a very simple question to the audience. How many of you have done any coding in your life? Okay, that's great. How many of you have done coding in Solidity? Okay, perfect. Okay, so what to do when transaction reverts and transaction reverts is swallowed? Like, what does it even mean for transaction reason to be swallowed? I want to show this piece of code. I hope it's readable from where you're sitting. Does anyone know from which library this code is? Does it look familiar to anyone? Especially this part, save ERC20, ERC operation did not succeed. Does this sound familiar to anyone? Okay, well, so this one is very personal to me. Like, it's a history which haunts me since 2020. This piece of code is from Open Zeppelin library. Open Zeppelin library is what you use pretty much in every single project that you do. This is a wrapper for ERC20 token, which you use to move tokens in a safe way. And what it does, it delegates the call to token, and then checks if it returned data, and then expects it to return Boolean. And if anything went wrong, it will just give you this error message. Save ERC20, ERC20 operation did not succeed. And what have happened underneath is that there was interaction with the actual token, and the reason for this failure is gone. Like, you will not see it in the result. So this is what we mean by error message being swallowed. Like, it's no longer visible. And this is a story from 2020. We were doing this project for a client. We were integrating other protocol and the balancer protocol, and these are very complex interactions between two protocols, which are hard to control. And actually, organizers of this event have been very nice, and they prepared for this presentation the depiction of how this project went. So if you look here, you will see the developer who actually is getting this error. For those who sit in the back, like, this was actually his face. And I am here, this is the helplessness I felt when, this situation happened. And in here you can see the client, like, he is holding a stick to our back and asking, like, why is it taking so long? And this is a personal situation for me because, like, the developer was so frustrated by carrying this cross on his back that he actually quit the job. Like, he told me that he's quitting the job because of this ERC20 operation did not succeed. And because I was this helpless, I figured out, okay, I need to do something about it, and we need to develop ways to debug these things in a manageable way. So how do you debug these things in a manageable way? You can do this by using this RPC call. So this debug trace transaction will, this is perfect, thank you, will give you a big JSON, which looks somewhere like here, and to make it more readable, it's a big JSON. It's a JSON which has 1 gigabyte or 2 gigabytes of text information. But if you want to know why your transaction reverted, you can actually search for revert. And every element of this big JSON is actually one state of your virtual machine. So whenever there is a revert reason, from the stack, you can read a position and the length of place in memory, which is pointing to an error. And in this particular situation, this is the reason for the failure, which has been swallowed. So this is how we were doing this back in 2020. And if you think it's bonkers, it is bonkers. This is not how you want to spend your days. So we had to do something better. So what does this better mean? Well, we started scripting around this. We developed some tools. And this is sort of like a meme that theory of automating some repeated task works like this, that you spend some time writing your automation and then you have like less work afterwards. And reality is that you spend some time and then you debug whatever you developed, and there is ongoing development, and then you go to events like this one and make talks about it, and then later on maybe it becomes a main thing. We are yet to learn what is here on the right-hand side. There is a QR code for the tool. The tool is open source and it's deployed on web. And I will show you how you can use it. So this particular situation, by crazy coincidence, is actually showing a transaction which I was debugging on ETH Global Hackathon, and one of the members of Hackathon is actually with us here. It's an easy project owner and manager. And he came to me on Hackathon. A lot of people come to stand of mentors and ask like, hey, can you help me debug why things don't work? So he already had code deployed to Sepolia. And we opened the transaction with failed, and this is what you see on Sepolia. So you can see this is not very helpful, and on screen it's even less readable. But the only thing you can see that this is a fail, and there is some status code. So now what you can do, you can copy this error message. You can go to the online tool EVM debugger. This is how it looks like. You can just paste this hash. You can select the network that you want this transaction to analyze, and it's a go. In this particular case, it will be very fast because it's already cached. If you do this for some transaction that it hadn't had chance to run through and cache, it takes 2 to 5 minutes, but this is very fast. So what it does, it simulates the entire transaction on the backend and extracts this very huge JSON file that you have seen before. And these bottom left part are actually all the states of virtual machine. It's a very, 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 very long list, and a lot of engineering has come into having this work as smoothly as it can. So this is like a basic data that it analyzed, but it also pulled all the sources of all the contracts that took part in this transaction, and it decompiled them. And most importantly, it is able to generate something like that. So what you can see on the screen, this is like an entry point, and then you can see all the internal and external calls that has been made by this transaction. And for the calls, we are also able to decode stack parameters, and you can see their values. And what is personally most interesting for me is that you can see these utility functions, these ULs. This is something that not many people in Solidity world are even aware of. So UL is a auto-generated code generated by Solidity compiler, which does all the heavy lifting. So anytime you have error about decoding or something internal, like this is the place of code, you have this error. And to my knowledge, neither Tenderly, no Remix will show you any of this, and we are able to extract it. So if you go to the very down, you can see that at some point it's calling panic error something. And if we click at this, we are moved to this frame. And now, now I'm using arrows up and arrow down to just time travel through the states of the virtual machine. And you can see that as I'm moving one step further, we are actually in a check division integer, and it's getting 2 parameters. It's checking if the second parameter is 0, and if you try to divide by 0, you will have a bad time. And we can move a little bit back, and actually until the moment where we reach the actual line of source code, and we can even see which division. So I hope it's okay. It's not very visible at this part. This division is highlighted, so you can actually see from here that total payout is 0, and that in this error we are dividing by 0. So that's one way to use it. Before I move to another example, I feel there may be some questions at this point, so I would like to address any questions that are concerning this part, and maybe move to the next one. Anyone? Okay. So I will show you another one, which is a little bit more more advanced. So again, there is, so this is a transaction which we'll be analyzing, and this is actually a transaction which succeeded. And what I want to, oh, sorry, this one I will actually close. So actually, this is a transaction which was doing some claim tokens with a Merkle proof, so like a Merkle proof verification. And the interesting thing is that you have a piece of code like this, a library that is looking at the proof. And from these parameters, we can see the entire proof decoded from the parameters. Oh, sorry. And what is possible, you can place yourself in any line of source code, and we can see in here that there was 12 passes through this line of code, which is understandable because it's a for loop, and for loop over 12 elements. And in each pass, I can jump to every pass, and for example, select a state in which Keccak is being called. And when I select a state where Keccak is being called, in memory, I will see what is the range, so what is the parameter that is being Keccaked, and EVM works in a way that whatever the result was is landing here. So like with this tool, you can inspect any internal state of your computation, and it's a post-mortem analysis, so it's a historical transaction, so you can just see with a magnifying glass what exactly happened and where. Okay, so I said about why, I said what we are doing, and maybe I still have a few minutes to say about how we are doing this. So the way we are doing this is that, like there is this diagram. Oh, no, sign up later. Go away. Okay, that's good. So essentially, this whole tool works in a way that user provides us transaction hash and chain ID, and we are using our backend. So the green part are backend components. So we are generating this trace, and then we have our main front-end store, which is in a front-end application, which extracts all the information about all the contracts which took part in this transaction, and then it's using another backend service to fetch the source code from Etherscan. So if on Etherscan we have source code of this contract, we are downloading the source code and we are recompiling it with the same flags to generate source maps. And we get something like that. If you cannot see anything, you are not really missing much, because this is as readable as matrix output, but we learn how to read it. And really, this is all the information you need to map the ranges of bytecode into the actual instructions of Solidity. And and I don't have time to explain this format, but it's very highly compressed and very efficient, and trust me, this is all we are using to get this done. So we are really combining all the states of virtual machine, all the source maps, and the source codes to get this interface. And what is important, and I'm jumping here, whoops. What is important is that this is all open source. There are two links here. One is our GitHub. So you are welcome, and all the code, like front-end and back-end, is in GitHub. So you are welcome to set it up locally, play with this. It takes 3 minutes to deploy front-end, which is hitting our back-end services. And this is the easiest way to start hacking with this. You can run back-end yourself, but back-end is AWS Lambda, so we need to know a little bit about AWS, but you are free to use Lambdas which are deployed on our AWS account, and I mean, it's a free tool. And all the analytic logic for extracting all this crazy amount of data, this is running on the front end anyway, so this is mostly the part that you could be interested in modifying. And there is our Discord server, and on our Discord server you can get help if you want to do something and are not sure how, and maybe we can do discuss things. So really this tool I think is a great asset for people who are doing security audits, because it allows for learning what is happening inside the transaction. And that's really all, because I saved 3 minutes for questions, and I will be very happy to answer any questions that any one of you might have. Yes, Tyler? Yeah, okay, I will repeat the question in case not everyone heard. Tyler asked, what are the different ways to supply us with a code that we will do analysis from? There are no ways. We only analyze code which has been verified on Etherscan. So whatever is verified on Etherscan, we will be able to pull, recompile, and use. That's all. Yeah. Maybe someone else has some other question. Okay, then.
Anybody has questions? Well, thank you. Maybe we can have a round of applause for Marek.
Thank you. Thank you so much.
Amazing. So I'm jumping in, guys. You didn't see me before because I was